PyTorch Policy Gradients, Essential Techniques and Tools. In this video, we dive into implementing policy gradient methods in PyTorch, equipping you with skills to build, optimize, and enhance reinforcement learning models.
Welcome to our deep dive into PyTorch Policy Gradients, Essential Techniques and Tools. Did you know that with the right techniques, you can significantly enhance your AI model's performance using PyTorch? Today, we'll uncover the secrets of implementing policy gradient methods in PyTorch, giving you hands-on experience in crafting and fine-tuning policy networks. Whether you're a developer looking to innovate or a researcher aiming to optimize, this video will provide you with the essential skills needed for building robust reinforcement learning models. Stick around as we unveil each step in this exciting journey. In this section, we'll explore the basics of policy gradients. Policy gradients are a cornerstone in reinforcement learning, allowing models to learn optimal policies through direct gradient updates. Unlike value-based methods, policy gradients focus on optimizing the policy itself, which is particularly useful in high-dimensional or continuous action spaces. The mathematical foundation involves differentiating the expected reward with respect to policy parameters, enabling gradient ascent to improve decision-making. Their importance in AI cannot be understated, as they provide a robust framework for training agents in complex environments. Real-world applications include robotics, game playing, and autonomous systems, where traditional approaches might falter. By understanding these fundamentals, you're setting the stage for mastering advanced reinforcement learning techniques. Before diving into implementation, let's ensure your setup is ready for PyTorch reinforcement learning applications. First, installing PyTorch is straightforward, with comprehensive guides available on the PyTorch website. You'll want to configure your environment to include libraries like NumPy and Gem for seamless integration and functionality. Essential tools like Jupyter Notebooks can enhance your development experience, enabling iterative testing and visualization. Adhering to best practices, such as using virtual environments, can prevent dependency conflicts and streamline your workflow. If you encounter issues, PyTorch's extensive community forums and documentation are invaluable resources for troubleshooting. With everything in place, you're now equipped to embark on your reinforcement learning journey with PyTorch.
Reward functions are the backbone of reinforcement learning, guiding agents toward desirable behaviors. Designing effective reward functions involves balancing exploration and exploitation, ensuring agents can learn optimal strategies. In PyTorch, crafting these functions requires an understanding of the environment and the desired outcomes. Avoiding common pitfalls like sparse rewards or overly complex functions can prevent stagnation in learning. We'll walk through examples of reward functions in PyTorch, demonstrating their impact on agent performance. By mastering reward function design, you'll empower your models to achieve high efficiency and effectiveness in complex tasks.
Building and training a policy network in PyTorch involves several key steps. Designing the architecture of your policy network is critical, with considerations for the number of layers, activation functions, and connectivity. PyTorch's flexibility allows for experimentation with different architectures tailored to your specific problem. Training strategies often involve gradient ascent methods, leveraging PyTorch's powerful Autograd feature for automatic differentiation. Hyperparameter tuning, including learning rates and batch sizes, can significantly impact performance, requiring a methodical approach to optimization. We'll delve into practical PyTorch code, illustrating the process of building and training a robust policy network, equipping you with the tools to innovate in AI. PyTorch's Autograd is a game changer in optimization, providing automatic differentiation for all tensor operations. This feature simplifies the process of computing gradients, essential for training machine learning models. Autograd tracks operations on tensors, allowing for efficient gradient computation during backpropagation. We'll explore optimization techniques that leverage Autograd, enabling the fine-tuning of models for enhanced performance. Real-world applications, such as dynamic neural networks and complex reinforcement learning tasks, benefit immensely from this feature. By mastering PyTorch Autograd, you'll streamline the optimization process, paving the way for innovative AI solutions.
Debugging is an integral part of enhancing model performance. Identifying common bugs, such as incorrect gradient computations or data preprocessing errors, is the first step. Performance bottlenecks, often caused by inefficient code or suboptimal hyperparameters, require careful analysis. PyTorch provides several debugging tools, including TorchViz and PyTorch Profiler, to assist in diagnosing and resolving issues. Iterative improvement strategies, involving systematic testing and refinement, can lead to significant performance gains. We'll examine case studies where effective debugging transformed underperforming models into high-achieving systems. By honing your debugging skills, you'll ensure your models meet their full potential.
Visualization is a powerful tool for interpreting and presenting model results. PyTorch offers several visualization libraries, such as Matplotlib and TensorBoard, to assist in this process. These tools allow you to plot training progress, visualize model architectures, and interpret outputs, providing deeper insights into your model's behaviors. Visual debugging techniques, like loss curves and activation maps, can reveal hidden issues and guide improvements. By leveraging visualization, you enhance your understanding of complex models, facilitating more informed decision-making and innovation in AI development. As we advance, exploring advanced PyTorch techniques becomes essential for pushing the boundaries of AI development. Advanced neural network architectures, like transformers and recurrent networks, open new possibilities for handling complex tasks. Transfer learning, leveraging pre-trained models, accelerates training and improves accuracy. Model ensembling techniques combine multiple models for superior performance, a strategy widely used in competitions. We'll also touch on state-of-the-art methods and future trends in PyTorch, ensuring you're at the forefront of AI innovation. By mastering these advanced techniques, you'll be well equipped to tackle the most challenging problems in AI.
As we conclude, let's recap the key learnings from today's video. We've covered foundational concepts of policy gradients, setup, and implementation in PyTorch, crafting reward functions, and optimizing models. I encourage you to practice these techniques and explore further resources to deepen your understanding. Engaging with the PyTorch community can provide support and inspiration as you continue your journey. If you found this video insightful, subscribe for more AI and PyTorch content. Your feedback is invaluable, so leave a comment with your thoughts or questions. Let's continue to innovate and elevate our skills together.